we have already completed the analysis of clocked sequential circuits with D flip-flop and with JK flip-flop. Now we are going to do the analysis with T flip-flop, and this is the last part, or you can say that the last lecture in this analysis part. And on your screen you can see the circuit having the T flip-flop, and the two T flip-flops are, let's say, A and B. The outputs are QA and QB. Now in this case there are two combinational logics. The first one is this AND gate, which is the input combinational logic, and the second one is this AND gate, that is our output combinational logic. So you know these things already, I guess. So let's start with our step number one. The step number one And the step number one is to find out the input and output equations. So I will start with the input equations. I have to find out the expression for TA and the expression for TB. That's actually very simple. TA is just the input. TA is my input and the input is X. Similarly, if I see for TB, it is the output of this AND gate, and the two inputs to this AND gate is QA. QA is connected like this, and the second input is X. So the output of this AND gate is X and QA, and that is the value of my TB, X and QA. Now we will move to the output equation, and output is the output of this AND gate, and the inputs are QA, QB. So Y is the output, and it is equal to QA and QB. As we have the input and output equations, we can now move to the state table. I will copy these equations and paste it, and I will drag it to the state table so that we can use it. Now you can see these two are my present state. One input X, this is the input, and the next state are QA plus and QB plus. We will start analyzing this state table, and the optimum goal of this state table is to find out the next state and the output. This is my output, and to find out the next state we must know the values of TA and TB. So I will first start with TA, which will help me to find out the next state of the A flip-flop, that is QA plus. So TA is simply X, so it is 0 1 0 1 0 1 0 1. I have TA, I have QA. I can use these two informations to get the QA plus, that is my next state. So let's start finding out the next state. QA is 0, TA is 0. TA 0 means JA is equal to 0 and KA is equal to 0. And when JA and KA is equal to 0, it means the memory. And when it is memory, we have the next state equal to the present state. The next state is QA plus, and the present state is 0. So QA plus is equal to 0. When TA is 1, J is 1, K is 1, it means toggling. We have to take the complement of QA, and the complement of 0 is 1. Again 0, memory, again toggling. So 1, 0, memory, 1, toggling, 0 is memory, so 1 is toggling, so 0. So this is what we got as the next state of my first flip-flop, that is A. Now we will move to TB. We have to find out the value of TB. It is equal to X and QA. We have to see QA and we have to see X, and we have to take their AND operation. 0 and 0 is 0. 0 and 1 is again 0, and as you can see, the four values, or the four first values of QA are 0, so definitely the four first values of TB is also 0. Then we are having 1 and 0, so it is 0. 1 and 1 is 1. 1 and 0 is 0, and 1 and 1 is 1. Now we have TB, we have QB, we can find out QB plus, like we did in case of T and QA. 0 means memory, so let me change the color for this. QB plus is 0, and 0 again, so memory, so 0, 0 again, so memory. In the first 5 cases I am having the memory, so 0 0 1 1 0 is there. 0 0 1 1 0 is the value of QB plus. Then I am having toggling, and the QB is 0, I will take its complement and I will have 1 then. 0 is again memory, it is equal to QB, so 1, and 1 is the toggling, the value of TB is 1, so it's toggling, and I will take the complement of QB and I will have 0. In this way you can see I have my next states QA plus and QB plus, and we will use this information to find out our state diagram. But we also need the output. The output is Y, and Y is equal to QA and QB. We have to just take the AND operation of QA and QB, and it will give us 0 0 0 0, again 0 0, and the last two cases are 1 1. So we have everything now to make our state diagram. I will do it quickly because you have sufficient knowledge about the state diagram, state tables. There are 4 states. The first one is S0, the second one is S1, the third one is S2, and the fourth one is S3. And when I'm having S0, it means QA and QB is 0 0, S1 is 0 1, S2 is 1 0, and S3 is 1 1. Okay, now we can use this table to find out the transition. Let's see for the first 2 cases. When I'm on S0, 0 0 is the value of Q and QB, it means I'm here on S0. If the input is 0, the next state is 0 0, it means I'm going to be on same state, that is S0, if I make the input equal to 0, and the output in that case is also equal to 0. So this represents my input X and this represents my output Y. Now we will see when the input is 1, I'm going to be on 1 0. 1 0 is S2, so I will be on S2 for the input equals to 1 and the output is 0 in that case. Now we will see these 2 cases. When I am on S1, 0 1 is my S1, I am here, and if the input is 0, I am going to be on 0 1, that's the same state for input equals to 0 and the output is also 0. When input is 1, I will be on 1 1. 1 1 is S3. When input is 1 and output is 0. Then we will analyze these 2 cases. When I am on S2, 1 0 is my S2. If input is 0, I am going to be on 1 0. It means the same state. The input is 0 and output is 0 again. If the input is 1, I am going to be on 0 1. 0 1 is S1. It is when input is 1 and output is again 0. We will see the last 2 cases in which I am on S3, and if input is 0, I am going to be on S3. So it is for 0 and output is 1 in this case, you can see. And the last case, when input is 1, I am going to be on S0 like this. The input is 1 and output is also 1. So this is the complete state diagram, and we have done the analysis by using the T flip-flop, and I hope it's clear to you all the 3 presentations in which we did the analysis using the D flip-flop first, then JK flip-flop, and now by using the T flip-flop.